Before holidays, we had a look at fuel cells, and there was a little bit of confusion about how fuel cells operate. So I thought I'd go through the PowerPoint that we went through in class, just so that you've got a resource for revision for your SAC and so on. So a fuel cell is just a type of galvanic cell. So remember, we've got our electrodes, which will only allow certain species to go through, because we don't want our reducing agent and our oxidizing agent coming in direct contact. So over here we have anode, okay, red writing, and over here we've got our cathode. So let's go ahead and have a look through this animation and see what happens in a fuel cell. So we've got a hydrogen gas. Our hydrogen gas can't pass through this electrode. It will only allow the hydrogen ions to flow through to our electrolyte in the middle. Over on our right, we've got our oxygen gas. So let's go through what will happen. In the middle between the electrolyte, in the electrodes, we've got our electrolyte. So it's really important that you have a look at what the electrolyte is, because there is a difference in your half equations. Okay, so this is an acidic hydrogen fuel cell. So that means it has hydrogen ions as the electrolyte. Okay, so those hydrogen ions play a role in part of the reaction that occurs. So we'll go through, let me just raise this, how this works. Okay, so over on our left, we have got a hydrogen gas. It can't pass through the electrode. It needs to be oxidized first. So what will happen is our hydrogen gas will lose 2 electrons. Okay. It will lose 2 electrons. Those electrons are forced up through the wire to the cathode. They can't pass through the electrode. It's lost those electrons and formed the hydrogen ions. The hydrogen ions can go through the electrode into the electrolyte. Those electrons have flown, not flown, along the wire to the cathode, where they've reacted or reduced our oxygen to oxide ions. So our oxygen is gaining those 4 electrons, forming the oxide ion. Okay. Then what happens is our hydrogen ions, which are cations, will migrate towards the cathode. Then what will happen is those oxide ions and the hydrogen ions will react to form water. Okay. This isn't a redox reaction. Okay. Remembering that our half equations, our redox reactions, always show the loss or gain of electrons. Okay, and if we have a look at this, we've got 2 negative, 4 positive, 4 negative, 4 positive, and 2 neutral. So it's balanced. Okay, so there's no electrons in here. Okay, it's not a reduction or an oxidation equation. So when we take these 2 reactions that are occurring at our cathode, our oxygen being reduced, and then these oxide ions reacting with our hydrogen ions, it will give us an overall reaction at the cathode. So if we cancel out what is doubling up, it would leave us with an overall reaction at the cathode of oxygen plus 4 electrons plus 4 hydrogen ions give us 2 water. Okay, and water comes out. So that is shown here in this reduction equation here. Okay, so our hydrogen gas is being oxidized. It's losing the electrons. They are forced to flow through the wire. The hydrogen ions will migrate, or a cation, they move towards a cathode. Our oxygen atoms will gain the electrons, forming the oxide ions. The oxide ions at the cathode will then react with our hydrogen ions to form water. And this is an acidic hydrogen fuel cell. So let's have a look at the difference with an alkaline hydrogen fuel cell. So if we have a look at this one here, the overall equation is the same. Okay, it's our half equations that are slightly different. So when we're looking at fuel cells, we need to make sure that we have a look at what the electrolyte is, because that will tell us the conditions that it's occurring under and will tell us what our half equations are. So we've got, let's put these equations up first. We've got our hydrogen gas going in. It's being oxidized. It's losing those electrons, and those electrons are being forced to pass through the wire. Then over on our right-hand side, our oxygen will be reduced. It's gaining those electrons. But this time, because it's under alkaline conditions, we don't have hydrogen ions. We're forming hydroxide ions. So these hydroxide ions, if you have a look at your electrochemical series, you'll see all these equations on there. So you just need to make sure that you're looking at the alkaline conditions, remembering that you're not forming hydrogen ions. So hydroxide is an anion. So that's going to move across to our anode. So we've already had our hydrogen gas, we'll write this down, so our hydrogen gas came in. I'm watching too. Give us our hydrogen ions, and we lost 2 electrons, okay? Okay, so that's what's occurred first. Then our hydroxide ions, which were formed over at our cathode, will move across to our anode, and they will react with our hydrogen ions. So we've got 2 hydroxide ions plus 2, what are it? That's 2 water. Okay, so remember there's no equations here. No electrons here. So we've got a hydrogen gas was oxidized first, and then those hydrogen ions are reacting with our hydroxide ions, which have migrated across to produce our water. So if we cancel out species that are the same, that will give us an overall oxidation reaction according to this. So we've got our hydrogen gas plus our hydroxide ions will give us water plus 2 electrons. Okay. So if we look at this equation here in the PowerPoint, we've gone wrong somewhere slightly. So we've got H2, which is neutral. We've got 2 negative here. We've got neutral, so this needs to here be 2 electrons. Okay, so I did a mistake. Okay, so that's 2 electrons there. Okay, so that's where this oxidation half equation comes from.